Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be talking about oxidation and reduction reactions, often known as redox reactions. So if you do enjoy the video, feel free to give it a like, share it with someone else, and please do subscribe if you haven't already. Thank you so much for all your support, and I hope you enjoy the video. So let's talk about oxidation first of all. This word has two meanings in chemistry. First of all, we can know of oxidation reactions such as combustion or rusting, but also oxidation can mean the transfer of electrons in the case of losing electrons. But let's just have a quick look at what oxidation in terms of oxygen means, and then we'll move on to those redox reactions as suggested at the beginning. So oxidation in terms of combustion, we have two types of combustion. We have complete combustion, where carbon dioxide and water will form, and we also have incomplete combustion, where there is a limited supply of oxygen when we burn a fuel such as butane or really any hydrocarbon, and we can form carbon monoxide, which is a poisonous gas. If inhaled for a long period of time, it's actually very dangerous because it can lead to fatalities. That is why we have carbon monoxide alarms in a lot of homes. But also carbon monoxide is quite deadly because it actually is odorless and colourless. So it's quite a dangerous gas. We can also form in incomplete combustion carbon, such which is a particulate. If inhaled, it can actually cause respiratory issues, and also water as well. So these are the two examples of combustion reactions of fuels, and we burn these fuels to release the energy that's within them. The other type of oxidation reaction is the rusting of iron to form iron oxide. And iron oxide essentially looks like a red material on the metal, on the iron, and it actually weakens the metal over time. If you leave iron out into the environment, into the exposed air, it will react with the oxygen and it will become oxidized. So that's just a bit of a rundown of the oxidation process in terms of oxygen. But let's have a look at oxidation and reduction in terms of electrons and the things you need to know for redox reactions. So in terms of oxidation and reduction, in terms of electrons, we need to remember the phrase oil rig. Oil rig stands for oxidation is the loss of electrons and reduction is the gain of electrons. And what we mean by that, in different ionic reactions or ionic equations, you'll be able to see the transfer of electrons from one substance to another. So in the case of this very simplified diagram, you can see that A and B react together to form A minus and B plus. The A minus indicates that the A product has actually gained electrons in this process, and the B substance has actually lost electrons in this process. Remember, electrons each have a -1 charge, and if you were to gain an electron as an atom, you would actually have more negatively charged electrons. You'd actually become more negative. Whereas if you were to lose an electron as an atom, you'd become a positively charged ion. Remember, atoms do not have a charge. Their overall charge is 0 because the number of electrons and protons are the same in quantity. But ions, if an atom becomes charged, it is now, we refer to it as an ion. Something to be aware of here as well, if we have, in the case of A, it's gained an electron, we can say that it has been reduced, or it's been there's a reduction that's gone on here. B, because it has lost an electron, it has become oxidized. Something to also be aware of in terms of metals and non-metals. If you ever get stuck in the exam, remember that all metals will form positively charged ions or cations, and all non-metals will all form anions or negatively charged ions. And the way to find the metals and non-metals in the periodic table is to remember that all the non-metals are on the right-hand side, and there's not many of them. There's quite a few non-metals, but most of the atoms, most of the elements in the periodic table are actually metals, including those transition metals that are in D block in the center of the periodic table as well. So that should help you out if you get stuck. So let's have a look at the things you need to know for your exam in terms of ionic and half equations. So there's a little bit of maths going on here, and there's a couple of things that you need to be aware of. So the first box, you can see a reaction, and we'll read this together. So we have magnesium, which is a solid. The state symbol S indicates it's a solid. It reacts with copper 2+, which is an ion, an ionic form of copper 2. And this is an aqueous solution, so it's kind of water-based. It also reacts with sulfate ions, so SO4 2-, and again, this is in an aqueous form. This essentially combines together in a chemical reaction to produce magnesium 2+ ions, which is now aqueous, the sulfate ions as well, and also the copper in a solid form. So you can see that there's a couple of things that have happened here. The states have changed, first of all, but also we have a couple of things that have stayed the same. So the one thing that stayed the same is the SO42 minus ion, and this is what we call a spectator ion. A spectator is something that looks out into the crowd and just kind of observes what's going on. So when we have to simplify and create half equations in the exam, you want to remove those spectator ions first of all, because they don't change in the different, they don't actually change at all in the equation. So remove those out and they essentially cancel out, just like you would in maths. If you have one thing on one side and one thing on the other, you can cancel those out. So we're left with magnesium plus copper 2 plus goes to make magnesium 2 plus and copper. Now we want to actually split this equation into two half equations to find out what has been essentially oxidized and what has been reduced. So we have our magnesium. Magnesium goes to make Mg2 plus, so it becomes an ion. It's actually lost electrons in this case. It's actually lost 2 electrons because, as you can see, it's gone from magnesium and it's actually become magnesium 2 plus. So it's actually lost those 2. It's become more positive. So the case would suggest that the copper has actually gained those electrons, but we can double check looking at the half equation. So we have copper 2 plus goes to make copper as an atom itself. It's no longer got a charge. So that tells you that because it's gained those 2 electrons, that is why it doesn't have those 2 plus charge anymore. Now I've put some electrons into this half equation for each case to actually balance those charges out, so the overall charge is equal on each side of the arrow, and we'll do some more practice of this as well. So as you can see, magnesium has gone to make magnesium 2 plus. However, we can't just leave it as magnesium 2 plus because the other side is just magnesium. We need to actually cancel that 2 plus charge out by adding 2 electrons on the same side as I've put there. And we want to do the same with the copper half equation. So copper 2 plus 2 electrons, those charges will now cancel out to form the copper. Essentially what we're doing in this case with the half equations is we are trying to balance the charges out and seeing what substances have been oxidized and reduced based on those charges. So as you can see, magnesium has actually been oxidized because it's lost those electrons, whereas the copper has been reduced because it has gained them. Let's have a bit of a practice at some more questions. So we have aluminium and it forms aluminium 3 plus 3E minus. Now this is just a example of a half equation. I want to talk you through it. So let's say in the exam you get this half equation and it's asking you what's happened here. You know, what's happened to the aluminium? You would actually say because aluminium has formed an aluminium 3 plus ion, it's actually lost 3 electrons. And that means because it's lost 3 electrons, it's actually become oxidized. That is why we have 3 electrons on the side of the aluminium 3 plus, so those charges cancel out. We've got 3 plus 3 minus, and they cancel out to 0, which is why they're on that side. So have a look at this other example. We've got a chlorine atom and it forms a chloride ion. What is actually happening in this half equation? Comment down below, and as always, I will leave the solution in the description box below. So here are a few more worked examples. We've got an ion, Fe2 plus going to make Fe3 plus. As you can see, the ion has become more positively charged, which means it has lost an electron, which is why we have to balance it out with adding an electron on the right-hand side. This therefore means on the left-hand side there's a 2 plus charge, and on the right-hand side there is a 2 plus charge too, because we have 3 plus an E minus, so 3 plus a minus 1 will equal 2. Therefore, because the ion has essentially lost an electron, we can say it has become oxidized. This is more of a challenging one with the Mn7 plus going to make Mn2 plus. We can see that we've gone from a +7 ion to a +2 ion. Now that tells you that there has actually been a gain of electrons because the ion has become more negatively charged. Although it's still positive, it's less positive than it was at the beginning. So that tells you that there's a reduction reaction that's happened here. And as a result, we need to balance the equation with the electrons again. So we have the 5E minus plus the 7 plus. That will take us to an overall charge of a 2 plus ion. And it's the same with the Mn2 plus on the other side as well. So we're trying to essentially balance out the charges on either side of the arrow by adding those electrons in each case so that they kind of cancel out and they're exactly the same. It's just like balancing an equation, but in this case, we're balancing the charges with the electrons instead. There's a couple more examples for you to have a go at and practice. I will leave the solutions in the description box below, but please do comment down below as well if you'd like more of these sorts of practice questions. I'm very happy to do that, and we can always do lots of conversations in the chat as well in due course. If there's any specific things you want to have more content on, I'm happy to do that as well. So feel free to comment down below. And like I said, the description box will contain all of the solutions for this video. And that's it from me today. Thank you so much for your time. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, please do give it a thumbs up, share it with someone else, and also do subscribe if you haven't already. It would be amazing to have you as part of our community. And thank you so much to everyone who already has subscribed. I cannot believe we are on 42 subscribers today. It blows my mind seeing people actually wanting these videos and being so positive about them. So thank you ever so much. If you do have any specific GCSE science content, whether it's biology, chemistry, or physics, you know, as always, I will link my videos on the side. I also have a social media, Instagram and TikTok, for all other biology, chemistry and physics GCSE revision tips and tricks. So if you want to check those out, everything is at the GCSE Science Teacher. And if you have any questions, queries, or you have any video suggestions, feel free to reach out in the comment section. It would be great to, support you guys, especially as you are heading for those GCSE weeks very, very soon. Thank you so much for your time. And in the meantime, have a great weekend and I'll catch you in the next one. Take care. Bye-bye.